Good morning and once again welcome to my YouTube channel, Pearson and Excel International Mathematics by Mr. Kamotho, and today we are introducing ourselves to Pure Mathematics 4, and this is the very first video uh, in that particular unit, and we were finishing Pure Mathematics 3, and now we are in Pure Mathematics 4, and we introduce ourselves to the very first topic, a very short one, which is called proof. And on page 2, we are going to see proof by contradiction. And a contradiction, as we know it, is a disagreement between two statements, which means that both cannot be true. Both cannot be true. So proof by contradiction is a powerful technique in mathematics. To prove a statement by contradiction, you start by assuming it is not true. You then use logical steps to show that this assumption leads to something impossible, either a contradiction of the assumption or a contradiction of a fact you know to be true. You can conclude that your assumption was incorrect and the original statement was true. There is something very important there we need to note, that to prove a statement by contradiction, you start by assuming it is not true. And I want us to just go direct to example 1 because we are told to prove by contradiction, prove by contradiction that there is no greatest odd number, that there is no greatest odd integer. There is no greatest odd integer. And of course, we have been told that to prove a statement by contradiction, you start by assuming it is not true. So our assumption is, what is our assumption? Our assumption is there is a greatest odd integer n. There exists a greatest odd integer. There is a greatest odd integer n. Let's call it just n. And of course, we know that if n is odd, and we know very well, if n is odd, then n plus 2 is also odd. It goes without saying, because every two odd numbers are separated by 2, because if 1 is odd, then 1 plus 2 is 3, 3 is odd, 3 plus 5 plus 2 is 5, 5 is odd, so n plus 2 is also an odd number. And the way we know it, since n plus 2, let's say, since n plus 2 is greater than n, and both of them are odd numbers, it goes without saying n plus 2 is odd plus even is odd. So what are we saying? That odd and 2 is even number plus even is equals to odd. And as long as we shall be having an odd number plus an even number, we shall continue to get odd numbers. So that means there is no end to the odd numbers that we can have. This proves what? So there exists an odd integer greater than n, of course. You can see it, an odd integer which is greater than n. because we had assumed that n is the greatest odd number. But we have added 2, or we have added any even number, and we have gotten an odd number. So there exists an odd number which is greater than n. This contradicts the assumption that the greatest odd number is n. Of course, we had an assumption that there's a greatest odd number, which is, it contradicts, this contradicts uh, since n plus 2 is greater than n, proves there exists an odd integer greater than n, then this contradicts, it contradicts the assumption, our assumption that n is the greatest, odd integer. Therefore, there is no greatest odd integer, meaning that, conclusion, since it contradicts, our conclusion is there is no greatest odd integer. And that is just it. There is no greatest odd integer. All right.